Hi everybody, in this video I'm going to show you how to use a potentiometer with the quantum system. So let's get started. A potentiometer is a 3-terminal resistor with a sliding or rotation contact that forms an adjustable voltage divider. They are typically used to control speed, voltage, or frequency. A potentiometer includes a knob to control the variable, a resistive element in the bottom, and a contact commonly known as the wiper. As voltage is flowing through the potentiometer, the knob can be turned to move the wiper across the resistive element and adjust the resistance used. This will then control the amount of voltage that passed through. The potentiometer typically has 3 pins that you need to connect to your circuit. There's the ground pin, the signal pin, and the power pin. Now that we have a better understanding of how the potentiometer works, let's go ahead and create our circuit. First thing you'll need is your potentiometer here. So this one is a rotating potentiometer. You have the knob here, which moves the wiper, and then you have your ground pin on the left, signal pin in the middle, and then power pin, which goes to 3.3 volts on your builder base. So now let's bring in our breadboard here. We are going to connect the potentiometer to the breadboard, just like this. Then now we want to attach 3 male-to-male jumper wires to those 3 pins. So the first one we need to attach is the ground. So that's the one that's on the left. So we'll go ahead and place it there, just like that. Next, we'll wire up our signal pin. Go ahead, take the purple jumper wire and connect that to the middle pin of the potentiometer. And lastly, take a red one, and we're going to connect that to the power pin on our potentiometer. There you go, just like that. Now let's go ahead and bring in our builder base. First one we're going to attach is our ground jumper wire here, just like that. Next, we'll take our signal jumper wire, and we are going to connect that to GP6. I chose GP6 because just the way these other 2 wires connect to our builder base line up, it's a little bit cleaner to do it this way. You can also pick any other GP terminal. Just make sure you assign those correctly when you create the firmware file. Lastly, let's go ahead and take our power jumper wire and connect that to 3.3 volts on our builder base. And there you go. Here's our circuit. So we have documentation on this potentiometer that goes into more detail on how it works and how to connect it with our system. So make sure you check those out. I'll provide that in the video description below. So now let's go ahead and power on our builder base and go pair it to our Q server. All right, now our builder base is powered on. Go over to the clients tab. Then you're going to go to the unpaired tab. And then for this builder base here, we're going to go to actions and then click pair. Once your client is paired, go ahead and click the setup button. Now let's give this client a name. Since we're connected it to a potentiometer, let's go ahead and name it potentiometer. And then for location, go ahead and pick a random location, whichever you prefer. Go ahead and click save. Now our builder base is paired. Next, let's go ahead and create the firmware file. So go over to the firmware tab, click create new. Now we're going to name this new firmware file potentiometer, and then click create. Now we have to add the potentiometer hardware to this firmware file. So go ahead and click add hardware, search for the potentiometer, and then let's go ahead and name it potentiometer as well. And then click add hardware. Now go ahead and click the drop down. Now for the driver, we're going to select GPIO. For the pin, I put it into the GP6 terminal. So I'm going to select that one. If you did one different, this is where you pick that one. There we go. And then granularity, we'll keep it at 50. Basically, what granularity is, if you just hover over the question mark, it tells you that it's the minimum change to notify the system. So since the potentiometer gives an analog value between 0 and 4095, it'll wait until it changes 50 values before it notifies the system. This is when you're typically using it for receiving data on your dashboard using an interface object. So your dashboard won't refresh with the new value until it changes by 50 values. But let's go ahead. We're going to keep it at 50. I'm going to click save. And now let's go ahead and upload this to our potentiometer builder base. So we'll select that one and then click upload. So while that's uploading, I'm just going to quit out of this. Let's go ahead and create our app. So go over to the Apps tab, click Create New. We'll name the app Potentiometer, click Create. Now the first thing we want to do is add that potentiometer hardware object onto that canvas here. There we go. Now for this first demo, I just want to show how we can read the data of the potentiometer using an interface object on our dashboard, and then we'll go into a little bit more elaborate demo afterwards. But for this one, I just want to read the analog value this potentiometer is giving us. So to do that, we are also going to search for a text interface object, just like that, and go ahead and drag that value port to the in port of the text. Now let's go ahead and name this hardware object for the mapping process that comes afterwards. We'll name it potentiometer. Click Save Properties. And then we'll also label and name the text object. We'll name this analog value, and we'll also label it that. There we go. We'll click Save Properties. And it looks like our firmware upload is done. So let's go ahead and save our app. Return to the My Apps. Click the play button. And now we'll map that potentiometer hardware object to the potentiometer client with the potentiometer hardware that we added to the firmware file. So go ahead and select that. Click Done. Click Save and Run. And now we'll go to our dashboard. And then we'll select that potentiometer app. And now you can see here in group 1, we have the analog value, which we labeled, and then this number here. So I'll bring out my potentiometer. Here we go. And now when I turn it to counterclockwise, it gives me a value of 0. Then when I turn it clockwise, you can see that number is slowly going up. And there you go, 4026. And then now I can bring it back down. So this is just how we can read the value. Yet again, like I said before, this potentiometer can be used to change speed, frequency, and values. So what we're going to do for our next demo is we're going to have this potentiometer control the speed of this DC motor that has a fan at the end of it, which is hooked up to another builder base that has a L293D H bridge controlling the speed. So when I adjust the values on this potentiometer, it is going to adjust the speed on this DC fan. So I already have the firmware uploaded for this setup here. So if you don't know how to do this, be sure to check out our video or the documentation on how to set all of this up. I won't be going through that in this video. I'll link that information in the description below as well. But let's go ahead, we're going to power this guy on and then go back to our Q server and then create the app for this. All right, now that we're back at our Q server, I'm just going to go ahead and stop this app. And then I'm going to pair that builder base with that DC fan. Click the setup, DC fan, studio, click save. There we go. Like I said, the firmware is already uploaded to it, so we're not going to do that. We're just going to go back to our apps tab. I'm going to go edit our app. And let's go ahead and keep this text analog value. That way we can see what the values are as the DC fan is spinning. And then next we're going to add in our motor hardware object, just like this. And then we are going to take that value and add that to the speed port on our motor. And then when you click it, make sure it says trigger. So when this value changes, it will turn on the fan. And then also, if you wanted to go a certain direction, like clockwise or counterclockwise, you can go ahead and just drag this. And this will just send a digital value of 1, trigger this so it knows which direction to spin. And then let's go ahead now and name our object. So I'm just going to call this the DC fan and then click Save Properties. And then now we're going to go to Save App, return to My Apps, and we're going to click that play button again. Now we have to map that DC fan. So I already have the client here. We named DC fan with the firmware file. Yeah, I misspelled it. Oh well. And once that's done, click Done. And then click Save and Run. So now that our app is running, let's just go ahead and go to our dashboard so we can read those values. But as you can see, we have a value 4 from our potentiometer. And then I have our, let me readjust here. We have our DC fan that's set up, and then our builder base with the potentiometer. So when I spin it, you can start to hear it go a little bit. I add more voltage through the potentiometer. There you go. Now the fan's spinning. As I increase it, you can hear it's getting louder. And then when I turn it back to 0, fan stops. So this is just one application of what you can do with a potentiometer. Like I said before, you can have it to control the speed, the voltage, or the frequency of something. And also a DC motor. It's pretty universal, so you can just switch them out too if you want. You can also use it for pumps, just like this thing. You can control the speed of that. So I'm excited to see what you guys end up using the potentiometer for. If you build something cool, please share it with us. We want to see what you are all building. So that's how you set up the potentiometer with the quantum system. Make sure you check out the links in the video description below for more information about this potentiometer, how to use it with our system, and for some ideas on how you can use it in the future. So I hope you enjoyed this video, and thanks for watching.